Hey there, it's me again, it's Saad. As you can see, there's a change of atmosphere. I'm visiting my cousins. This is my cousin. He's really shy. Okay, so today I'll be making a video on maths. It's the Pythagorean theorem or the Pythagoras theorem. So this theorem, a theorem is kind of this mathematical equation that's been proven to be true. And Pythagoras was this ancient Greek mathematician. So what happens is this just tells you about the properties of a right-angled triangle. You know sorry for the cut. My mom just keeps on changing my view. So as I was saying, there are lots of types of triangles. There are the normal triangles, but there's some triangles which are kind of like this. So there's a right angle in them. A right angle is an angle which is 90 degrees. It's kind of like this. You see it all the time in squares and stuff. But what happens is these right angled triangles, this man called Pythagoras in ancient Greek, he figured out a way to calculate when one, like if you knew two of the sides of a triangle, you could calculate the third by the Pythagorean or Pythagoras' theorem. Well, here we go. Okay, so first of all, you need to know what are these triangles. I think I'll change this. Yeah. Okay, so there are often this right angle triangle. You can see it's right angled because it has a 90-degree angle. Oh, it's a little too big, I think. Oh, come on. Okay, you know what? This is all right. Yeah, it's all right. There's a 90-degree angle, and this is that angle. I think I should undo this. This is a 90-degree angle, and this is that angle. Okay. These two sides are called the legs. The legs, yes. These, I think I should undo this. Yeah, undo, yes. So these sides, the legs are the sides of the triangle that are connected to this. That, for example, because this is connected to this part of the right angle. Oh, I've made it wrong. Wait. So this is connected to the right angle because this is a right angle. This is connected, so this is a leg, and this is also connected, so this is also a leg. But this part over here, this is called a hypotenuse. So this is kind of the part that is the opposite of the, oh, come on. Oh, I didn't know you can do that. Anyways, it's opposite of the right angle. Yeah, it's opposite of the right angle. Don't mind my cousins. It's opposite to the right angle, and this is known as the hypotenuse. So this is what we'll be talking about. Okay, so let's say we take this situation. There's a right angle triangle. And we know two of its sides, the legs, we know it's 2 centimeters and 4 centimeters, but we don't know the hypotenuse, which is x centimeters. Now, Pythagoras came up with this brilliant idea. If you take, let's say we call one of the legs A, I'll call this one A, and the other leg B, and we call the hypotenuse the C. Well, he said that if you know A and B, you can calculate C via, well, you need to know a little algebra and degrees and stuff, but that's all right. And exponents. A squared, squaring, I remind you, is just the same as A times A. So A squared is A times A, B squared is B times B. Okay, A squared plus B squared is equal to C squared. Oh, okay. I don't know why it loves doing that, but just don't mind it. So, so here we go. A squared, let's do the calculations. A squared plus B squared is equal to C squared. Okay. Now you take this. Let's say now we plug in the values. Now A is 4 centimeters. squared plus b is 2 centimeters squared is equal to c squared. Okay, please stop. Okay, now 4 squared is the same as 4 times 4. If you know your times tables, then you'll know it's 16. 16 plus 2 squared is just 2 times 2, which is 4, is equal to c squared. Oh, come on. Okay, now what is 16 plus 4? Of course, 20 is equal to c squared. Now, what we have to do is take the square root. Now, the square root is kind of like the opposite of square. So, for example, if you square 2 squared, it becomes 4. If you take 2 and you square it, it becomes 4. But if you take 4 and you take the square root of it, it becomes 2 again. So it's kind of like the opposite of squaring it. So what we have to do, I'll just rewrite it so it's a little bit easier, 20. So what happens is c squared is equal to 20. So what you do is you take the square root of both sides is equal to square root, square root of 20. Now, because these two are the same, they cancel out, so you're left with c squared. C is equal to the square root of 20. But square root of 20 is very hard to calculate because it's not one of the perfect squares. So I can just write it down and use my handy calculator. Square root of 20 is equal to... Oh, it doesn't work, does it? Square root of 20 is equal to... It doesn't work. Uh-oh. In that case, I'll just finish it as c is equal to the square root of 20. And using a calculator, c is equal to... So c is equal to 4.4721, and the numbers keep on going like pi. Remember pi? Yeah. Okay, so this was problem number 1. Here's the second one. What if you know one of the legs and the hypotenuse, so you know A and C, but you do not know B? Well, we just have to rearrange the formula literally. Let's say A squared plus B squared is equal to C squared. Okay. Wait, let me just see what it does. A squared plus B squared, let's say, is equal to... Oh, I wrote it too untitledly. A squared plus B squared is equal to... Yeah, see? It doesn't do anything, huh? Okay, so as I was saying, I'll just rub those out. Yeah, goodbye. Okay, so as I was saying, this a squared, we know what a squared is. 1 squared plus b squared, which we don't know, is equal to c squared, which we know is 3 squared. Now 1 squared is not 2, but what is 1 times 1? 1. Anything times 1 is equal to itself. Anything. Except for 0, because 0 times 1 is just 0. Yeah, actually, yeah, that too. And yeah, that's it. So that would just be 1 plus b squared is equal to 3 squared. Huh. No, thank you. Is equal to not 3 squared, but 9. So now we just need to rearrange the formula, which is we just subtract 1 from both sides. So that will be b squared. Actually, there's another way of doing this. You can just bring the 1 over here and get it the other way. B squared is equal to 9 minus 1. Ooh. Okay, b squared is equal to... Well, okay. Let me try that again. Okay. Squared is equal to... Oh, that's 6 squared. I get it now. is only been mistaking my b squares for 6 squares. Anyways, b squared is equal to 9 minus 1, not this, is equal to 8. So that means we need to just take the square root. So square root and square root, that'll just leave b is equal to the square root of 8. Now let me try that again. Maybe it'll work. Square root of 8 is equal to, oh, it works. 2.828. B is equal to 2.828. Well, there's your next equation solved. Huh? Oh, I think is that it? No, there was another one. I remember. Oh, that was it. Anyways, that was it about the Pythagorean theorem. Come to life. It literally just came to life. Anyways, that was it for this video. See you next time. This is my cousin who is making all the noise.